Look closely at Kampala. Every glass tower, every concrete block, and every paved street in this dense urban grid was pulled directly from the earth. We've built an entire civilization by extracting the ground beneath us, and it goes beyond our cities. When you step outside the capital and look at the terraced hillsides, you see our food supply and our massive export economy growing directly out of that exact same dirt. Further out, in places like Karamoja, the earth pushes upward into raw, jagged mountain peaks that dwarf human settlements. We tend to treat this ground as permanent. We walk over it assuming dirt is inert dust and rock is a static, dead building material, completely blind to the slow, violent chemical reactions happening constantly beneath our feet. To understand how Uganda manages to build its cities and feed its millions of people, we have to look past the surface and break this landscape down to the molecular level. Let's zoom in on a single, rough piece of granite. If we get close enough, we see that what looks like a solid gray stone is actually a chaotic mosaic of different colored flecks and shiny crystals. Those individual shiny flecks are minerals. A mineral is a pure, naturally occurring chemical compound. Think of it as a single isolated ingredient, like flour or eggs. A rock is a composite. It's what happens when nature crushes several different pure minerals together into a single solid mass. If minerals are the raw ingredients, like flour and sugar, then the rock is the final hardened cake that comes out of the oven. Because rocks are mixtures of these pure elements, geologists can look at the physical texture and color bands of any stone and read the exact recipe the Earth used to forge it millions of years ago. This flowchart illustrates the rock cycle. It shows the 3 methods the planet uses to bake those mineral mixtures into new land masses. The first method creates igneous rock. Deep underground, temperatures are so high that raw rock melts into a liquid called magma. When that magma erupts and cools, it crystallizes into extremely hard stones with visible speckled patterns. The second method produces sedimentary rock. Loose sand, mud, and crushed shells wash into lakes and oceans. Over time, millions of years of gravity and water pressure crush those loose particles together, pressing them into flat, horizontal layers. Finally, we have metamorphic rocks. When existing stones are dragged deep underground, intense planetary pressure and extreme heat physically warp them. Those neat, flat layers get violently squeezed into wavy, distorted bands. The mountains and bedrock we build on aren't permanent fixtures. They are temporary stages in a massive, endless recycling machine. But the moment these heavy stones are formed and pushed to the surface, the environment starts tearing them down. Nature destroys solid rock through a relentless process called weathering. The first type is physical weathering. The hot equatorial sun heats the rocks during the day, making them expand. At night, the temperature drops and the rocks shrink. This constant expanding and contracting eventually causes massive boulders to shatter. Next is biological weathering. Living organisms actively hunt for weak points in the stone. Tree roots find the microscopic cracks, wedge themselves inside, and pry the heavy rock apart as they grow. This diagram illustrates chemical weathering. Rainwater is naturally a little bit acidic. When this water lands on certain stones, like limestone, it chemically reacts with specific minerals, literally dissolving the rock from the inside out. This violent destruction is completely necessary. Weathering is the precise mechanism that transitions the planet from a barren geological crust into a biologically active environment. As these rocks weather, millions of tons of solid stone are pulverized into tiny fragments. They break apart into gravel, sand, and silt, and microscopic clay particles. When those pulverized, mineral-rich rock grains mix with decaying organic matter, they form fertile topsoil. Look closely at the lush coffee crops on the slopes of Mount Elgon. Those plants thrive specifically because, over thousands of years, the ancient volcanic rocks beneath them were systematically destroyed, releasing their hidden nutrients into the dirt. To sustain fragile life, the hardest, most permanent structures on the planet must be completely broken apart. The ground beneath our feet is a relentless, ongoing chemical cycle of creation and destruction that continuously pulls mountains apart to build our cities and feed the nation.